Hello and welcome to another mining podcast with me, Paul Harris, and co-host Joe Mazumdar. Good afternoon, Joe.
Hey, Paul, how's it going?
Very well, thank you. We've got a very interesting podcast this week. Our guest is James Tickner, CTO, that's Chief Technology Officer and co-founder of Chrysos Corporation, a company many people have never heard of. It's an Australian company doing wonderful things in terms of gold assaying. Hi, James. How are you?
Hi guys, good to talk to you.
Now, Chrysos, you're making waves in the gold exploration space with your photon assay technology, which is a replacement, or is going to be, or could become a replacement for the traditional fire assay method, which has been around for thousands of years. Is that pretty much what we're going to be talking about?
Yeah, no, absolutely. We've been around for a few years now, sort of developing this technology. I think we're just sort of breaking the back of getting people to accept that there's perhaps better ways out there for assaying gold. Yeah, look, happy to chat to you guys today about what we're up to and where we're hoping to get to with it.
Maybe
Excellent.
what we got to start at is the background as to how we actually assay for gold right now. Could you go through that, James? How it's actually done now in terms of a fire assay? What does that look like?
Yeah, sure. So I mean, look, there's a few different methods out there, but fire assay is sort of no pun intended, the gold standard. So typically, companies would send samples that they want assayed through to the lab. Lab would receive those, crush them, pulverize them down to a really fine powder. And then there's quite a long, complicated chemical process. They mix in typically lead oxides, heat the sample in the furnace, the gold dissolves into the lead, and then there's a whole bunch of steps by which they can extract the gold out, dissolve it in acid, and then do a final instrument analysis. So pretty labor intensive, pretty time consuming, and there's some sort of nasty reagents like the lead that get involved in the process as well.
Okay, so how does your process, the photon assay process, work? What are the key elements of that? What are you doing differently?
Sure. So it's a completely physical process. So there's no chemistry involved, and it's actually a non-destructive process, which means the sample that goes in is the same as the sample comes out. So we use very high energy X-rays, and they excite any gold nuclei. So that's the central part of the gold atom that might be present in the material. Those nuclei become excited, and then they give off a signature, a pulse of gamma rays that we can measure. I guess a lot of your audience might be familiar with X-ray fluorescence as an X-ray method, X-ray fluorescence, XRF. So widely used, but not really very applicable for gold. The X-ray energies that we use are about 100 times higher. So it's much more penetrating, which means we can see all the way through a big, substantial rock sample. And it's also much more sensitive. So we can get down to very low detection limits. We can see the sort of levels of gold that people might be looking for in exploration or mining operations.
Okay, do you still have to crush the drill core, or just a chunk of drill core and you go at it on that?
So we do need to crush the sample up. So when we're measuring the samples, they get put into a standardized plastic jar. That's about 100 millimeters or 4 inches in diameter, holds about half a kilo of rock. So typical sample prep would be to crush the material to a top size of 2 or 3 millimeters, put the material into the jar, and then just post it into the machine. So still a little bit of sample prep, but certainly a lot less than people would be used to with traditional assay methods.
Okay.
So the big difference here is we're talking 2 to 3 millimeters versus maybe 75 microns or 150 microns in terms of what
absolutely.
they do with the fire assay.
It's just with fire assay, you're measuring such a small mass of material, maybe 30 grams, 50 grams. You've really got to pulverize it down fine to try and get a representative sample. Once you're happy to measure a much bigger mass of material, much less prep is needed.
So for our audience, we can have bias with the actual drill hole. You could actually miss where the gold mineralization is, and the lab will not pick it up, obviously, because there is no gold in the sample. But then you're taking a 3 or 4 kilogram sample, sending it to the lab, and right now they get a 25 to 50 gram aliquot that they basically assay for the gold. If the gold's not in there, they don't come up with a gold assay. And that could be a problem if the gold is not evenly disseminated and maybe very coarse, which is something that you've dealt with, I guess, because Fosterville, which is a high grade gold deposit in Australia, uses this technology.
Yeah, look, Fosterville is a good example. I mean, the point you made about if the gold doesn't end up in the sampling you measure, in the sample that you're measuring is spot on. If that 25 or 50 grams of material you take for a fire assay, you happen to get unlucky and there's no gold in there, then you won't see it. Or conversely, if you get a big fat gold nugget in there, you might get a sort of an off the scale reading, but it's not giving you a sort of a representative value for the average of the material that you're looking at. So yeah, if you gave that example of sort of 3 or 4 kilos, we would typically take a half kilo sample from that to measure. But we've certainly had some customers where their gold grade is or their gold distribution is very, very coarse. They might actually choose to put the whole sample through photon assay. You split it out into 6 or 7 or 8 jars, run the whole sample through, and you're really getting the entire sample measured. You've got no sampling issues in the lab there at all, which can be a big win. Look, coming back to Fosterville, sort of where we started the question. They took a unit from us. I think it'd be a couple of years ago now. Their interest was very much around the difficulties of dealing with coarse gold. They've run pretty extensive test work now, a lot of sort of cross validation of photon assay versus traditional methods, and the indications are they're very happy with the results they're getting.
Now, you've got obviously a very established competing technology that you're going up against. Fire assay been around for thousands of years. So we were talking about this before going on air, so to speak. The 3 main things that are important here are the reliability. That's fundamental because people make investment decisions based on the results of assays. But then the secondary aspects are the cost of the procedure and the time it takes to get the results back. I imagine there's some sensitive information here, but how does the photon assay process stack up against fire assays on those 3 elements?
Yeah, sure. So I mean, look, the first point you make there, the technical issue of are we actually getting the right answers is critical. I don't know if it's unfair to say gold's a sort of a commodity that perhaps attracts more charlatans than any other commodity out there. There always seem to be people promising better methods or new ways of doing things. So we did really substantial validation on this technique. I mean, before we even created Chrysos as a company, I used to work for something called CSIRO, which is the Australian sort of National Applied Research Lab. We did about 15 years or so of development on this technique to show that it actually works, establishing all the basic science, doing a lot of cross-validation against certified materials and different ore types. After we started Chrysos and we had our first production unit up and running and could run much larger volumes of materials, we've now run it would be probably 70, 75 studies with most of the world's largest miners, in aggregate hundreds of thousands of samples, and doing pretty careful statistical validation. So photon assay versus fire assay and versus sort of other analytical techniques as well, like leach or screen fire assay where it makes sense, to establish that we get consistent results, that we get results that show less variability, less bias than traditional methods. In terms of cost, so there's no getting around the hardware that we provide is a pretty complex and expensive bit of gear. But the model we use is we don't actually sell that hardware to labs. We sell a service. So essentially, we provide the gear, we support it, we keep it running, and then customers pay us effectively by the sample that they put through the system. In terms of just sort of cost of analysis, we're generally compatible with, or in many cases, somewhat cheaper than a traditional fire assay analysis. And because you've got a lot less sample prep to do, you're saving on the sample prep costs as well, which, as I'm sure many of our listeners know, is often a considerable part of the total price. Sorry, you're gonna have to remind me the third part of your question.
The time to complete the sample and get the result back.
Sure. So the actual analysis itself through the machine takes about 2 minutes. So generally, that's not the bottleneck in the process. Usually, the sort of the longest times involved are receipt of samples at the lab, scanning them in, the crushing, and then putting through the machine. But because that preparation side is a lot more straightforward, and because all of the tracking through the samples through the machine is fully automated, generally that's a lot quicker than or is a lot less labor intensive than traditional assays. So certainly people customers are finding the overall turnaround time is generally a lot less than they're used to seeing.
And so for an assay lab that gets one of these bits of kit, presumably then less sample prep time and a quicker assay time, then their throughput could potentially increase quite significantly.
Yes. So I mean, a good example there would probably be the Min Analytical. So that's the lab in Australia that took our first 3 systems. They were a sort of medium-sized lab when they took the first system. They significantly increased the volume of material that they're putting through their labs now. Lower prep requirements, faster analysis, less steps in the process just means it's easier to get samples running through the system.
Okay.
So right now we're dealing with a lot of labs, in 6 to 8 week turnarounds or more, especially in North America. If they were using your technology, would that change much?
Yeah, I mean, look, I'll be candid with you. It's difficult to be kind of quantitative there because it's mostly driven by the processes that the lab themselves have got set up. It's not the sort of the analysis back end. But just looking at the reduced requirements for preparing materials, the lower labor requirements for actually running the analysis itself, I think most labs should be able to get a better turnaround time than they're doing at the moment.
So just to get an idea, like we're talking about, bigger samples, which is exactly what you want with gold. Always the bigger the sample, the better. Easier reproducibility of the samples. You don't have to go to a pulp and then re-assay it. Lower preparation because you're dealing with coarser samples, no chemicals required that you got to dispose of, less skills required, potentially less sampling bias as you handle the material less. So what's the downside of this? What is something that holds this technology back that maybe some people may not find this something that they could do right now?
I think it's because it's new. If I'm sort of completely candid, I mean the mining industry is sometimes has a reputation for being a little bit conservative about new technologies. Assay is obviously something that kind of critically underpins the business, whether it's exploration, whether it's resource definition, whether it's mining, whether it's processing. If you don't believe your assays are correct, then you're really questioning the data that you're using to run your business. Our experience has been a sort of an initial slow uptake of the technology. A huge interest, lots of people sort of running complex validation studies with us. Really, as we've seen those validation studies go through, as we've seen larger mines, larger operators kind of start to engage with us on the technology, I think we're just getting to that sort of turning point of seeing the industry accept this as a normal way of doing things. But I guess it's that traditional sort of S curve, a slow initial adoption and then a sort of a faster uptake as people come across.
Now, you mentioned that your model is to sort of effectively lease the machines out, or you put the machines in and people pay you on a per sample basis. What is the sort of lead time for a lab to be able to get one of your machines?
Fairly long at the moment because we're sold out until certainly well into 2023 now. We're ramping up our sort of manufacturing capacity for those units. We've just deployed our 7th unit. By the end of next year, we should have something like 15 or 16 units deployed, and then looking to get to sort of a dozen plus units rolling out thereafter. But the thing driving lead time at the moment is just that the manufacturing pipeline is sold out up to unit 20 something at the moment.
And is that a working capital issue for you guys, or is it just how they're made and where they're made?
Not so much working capital. I mean, we've just completed a big raise, and we're looking to list on the Australian market next year. So there's sort of reasonable source of investment capital there. The technology is quite complicated. It's got this X-ray source which based around a linear accelerator, which is quite a complicated bit of gear. The robotic systems that move the samples around, just all the bits and pieces that go together is there's just a lot of manufacturing effort goes into that. We are ramping up that capacity, but it's you can't go overnight from making a few machines a year, which is where we've been for the first few years of our existence, to making 24. Just scaling that ramp up as demand comes in from the industry. It's going to be our sort of really the focus of the company for the next few years, I think.
Has it been more readily adopted in Australia because that's where it came from? But now we see like Barrick is using their own lab or a lab to use their to assay their mine samples in Tanzania. Is that going to help? Is help with the adoption of the technology further afield in Australia?
Yeah, look, we hope so. I mean, our first 6 systems all went into Australia. So mostly in WA with Min Analytical, and then recently with Intertech. And then we've got the one unit we've mentioned over in Victoria with Fosterville. So the Barrick installation in Tanzania is our first international installation. If I look at our deployment board for the year ahead, most of our systems are now going in overseas. So we've got a couple of systems going into Canada next year. I'm just looking down the list here, 3 or 4 more systems going into different locations in Africa, and then a couple more Australian installations. Look, certainly getting that first international installation with a top tier company like Barrick helps. It kind of hopefully gets the word out that we're a serious technology. Major players like Barrick that have done all of their due diligence are saying, look, this is something that we're happy to go with.
And like, just as we end this, I mean, we're talking about you replacing an old methodology to assay for gold, specifically coarse gold, but I guess you could use it for finer gold mineralization. What other commodities could you possibly use the system for, and do you need the same kind of adoption sort of S curve for those as well?
Yeah, so look, we're certainly tackling a number of other commodities. First cabs off the rank for us are silver and copper, and the Tanzanian, the Bulyanhulu installation is interesting there because that's our first commercial deployment of both of those additional analysis services. Silver's nice. It has very similar nuclear or activation properties to gold, which means that we can actually measure both of those elements at the same time as part of the same analysis service. Copper, we change the operating conditions of the machine. So essentially, we have to put the samples for 2 passes through the machine. So they'll do a loop where we do the gold and silver analysis, and then a second loop that we can do the copper analysis. Today, our focus has been very heavily on gold and gold-associated elements, so silver and copper. In principle, we can do a range of other base metals, lead, zinc, tin, uranium, for example. They're not a heavy part of our development focus at the moment, but they're all certainly kind of accessible to the technique. And if we achieve our aim and sort of saturate the gold market, then we'll certainly start to look at some of those other applications as well.
Okay.
Well, it sounds like you've got a bright future ahead of you, James. And we haven't mentioned, but it's worth mentioning now that Chrysos, the Greek word for gold, and it sounds like you're on your way to making quite a lot of that fuel for the company as well.
Hopefully. I mean, look, I'm a scientist and a sort of engineer at heart, and I've always worked in the space of trying to solve technical problems, and that first and foremost is what motivates me. It's fantastic to see a technology that you've worked on for so many years actually being adopted and being used. I was on a site last year, and bloke sort of turned up with a ute full of bags of material and sort of said, "Oh, we've got a bunch of samples here to be photoned," and that made me very happy when you've kind of become a slang term. Perhaps says that you're starting to get a little bit of acceptance.
Okay, well, somebody can Google what that means, and pretty soon we'll be photoning everything for gold. So thanks a lot, James. We really appreciate it, and look forward to not only as this technology advances, but the listing of this company on the ASX next year.
Oh, fingers crossed. Thanks, guys. Enjoyed the chat.
Okay. Thanks,
Thanks
Paul.
thanks very much, James. Yep, that's all for another mining podcast this time round. Thanks very much to James Tickner, CTO and co-founder of Chrysos Corp in Australia. Thanks, James.
Thank you.
And that's all from me, Paul Harris, and Joe Mazumdar for another mining podcast.